Hello everyone, and this is a final animation that I prepared for you. And the real main purpose for this one was to create not only RBD destruction but also denting metal of the car, as you can see here. So I prepared all the setup, and you can download it from my Gumroad. I will leave a link in description, but I will also provide you a quick walkthrough this file, and we also try to make a replicate of one piece of this car. So let's begin. So this is the final one that we gonna to recreate, and you can see that we created denting metal here, and I will show you how to do this from scratch, and we talk only about one part of the car. So let's delete everything. So this is a model that I prepared in Cinema 4D, and I prepared it for destruction in Houdini. And important thing to know that if you want to break something in Houdini, and if we are talking about specific parts, you have to separate it in different groups. For example, if we just will make a blast and choose body and body 1, lead not selected, that's the part that we're gonna to break. So that's important thing to know about destruction of the car, and also different objects that we have in the car. Okay, so let's start with this car. As you can see that it has a large scale. So let's first of all let's make a convert and convert everything to polygons. Make transform node and also make it smaller. It's gonna be 0.1. So now we have something about 4 meters of a car. So this is plus minus real dimensions of the car, and make a blast. That's what we have now. And also let's make a zero position of a car. So let's make another transform. Let's give it a value of 2.5 in Y. In rotation X, let's gonna make 40, and rotation Y, let's gonna make 30. Okay, that's gonna be our zero position. And now we have to break it in Voronoi. So we're gonna have smaller pieces of this car. So let's make a scatter node, and let's go and scatter 100 points and plug it to Voronoi fracture. So zero position we plug in first input, and scatter node we're gonna plug in second input. And also let's uncheck create interior surfaces, because that's will fix these ugly edges. Now we have a normal one, and let's see how it looks in exploded view. That's all the pieces we have now, 100 pieces. So let's create a pocket, because now we have polygons, and let's create pocket objects for our destruction. So let's make assemble node, uncheck create name attribute, we will create our attribute, and uncheck connect inside edges, and let's check create pocket geometry. And now we have 192 pocket fragments. So in order to simulate in a proper way this part of a car, we have to give a unique name for every point. So by default we have a name attribute, and it's called piece. But imagine that you also will have tires and glass and other object of the car, and every object that you will go to destruct, wanna do a destruction for it, you have to give them a unique name. So let's create unique name for our body part. So let's go to make a point triangle, and let's rename our name attribute for different name. So let's call it body %d. It will numerize our points, and it's going to be on our points. And now we have a name attribute with body 0, 1, 2, 3, and till 191. And it's going to be our out packet object. So out body packed. And we also have to create a constraint. So by default, within 17.5, we have a constraint geometry that's created by Voronoi fracture, and we can use it. Let's create a replicate of our name attribute, and that's a constraint that we're gonna have in our car. So let's also create connect adjacent pieces, and let's make it connection type adjacent points, and increase search radius for 0.3. And now we have a little and we have now more connection points. That's gonna help us in RBD simulation. So let's also create constraint name for our constraint. So let's give it primitive wrangle. So constraint name, it's gonna to be soft body, and constraint type gonna to be all. And one main thing that we have to do this here, and we have to give length attribute, rest length, and I will show you why we have to do this. So check length attribute, and that's going to be our out soft body constraints. And let's replicate everything that we have here, and make in primitive angle, let's change it to glue body. Okay, and let's call it glue body constraints. So that's all the setup that we have for denting our car. And now let's make a DOP network. So let's make a DOP network. Let's call it sim car. Dive inside. What we have to do, we have to put our gravity. We need to put ground plane merged. I will make it mutual. We have to create RBD packet object, RBD packet object, and let's bring our out body packet. Okay, and connected to rigid body solver, and connected to our merge. So now you can see that we have a simple rigid body destruction. Okay, so but we created our constraints, and we're gonna to put it here. So let's make a constraint network, plug it after rigid body solver. In second input, we have constraints to create. We created two types of constraints. It's a bullet soft constraint relationships and our glue constraint relationship. Let's make a merge and merge this constraint together. And we have to specify a subpath. So let's plug here our soft body constraint. And our data name of our constraints is going to be soft body. So now you can see that we bring our constraint here, and let's uncheck guide options, and let's simulate and see what we have. So now you can see that soft constraint created this type of animation. And as you remember, I told you about rest length attribute. For example, if I will disable it here and make a simulation from a start, you see that all the car is squishes. And that's a reason that we have to check here length attribute on. So now let's get initial speed to our car. In RBD packed object, let's make velocity 10 in Z direction and minus 10 in Y direction. And that's what we're gonna have now. So in order to keep our mesh together, we have to increase stiffness in bullet constraint. So let's make it 50. And that's what we're gonna have now. And the reason we created glue constraints, and let's spell it here, glue body. So this is the name that we gave to our constraints here, glue body. And we have to enable it, because after we have our blue soft constraints, we have to keep a mesh. So in order to keep a mesh, we have to enable our glue constraints. In order to enable glue constraint, we have to create enable solver. Okay, and we have to use subsolver connected to enable solver. And in the relationship geometry, let's make a primitive wrangle, not a point but a primitive wrangle, and let's change our constraint name to glue body. And let's see, this car have animation, and in frame I think 6 we have accident. And so let's enable here our solver. So glue constraint will gonna to be activated after frame 6. So in frame, if a frame number is going to be more than 6, it's going to be to switch from bullet soft to glue constraint. And that's this one, as you can see, will keep our mesh together. Let's try to decrease our stiffness if in the bullet to 25 and see what we have. Okay, I will keep it to 25. I like how it looks now. Okay, so that's all for our simulation, and let's see how we can bring it to mesh in SOP level. So in the SOP level, let's create a DOP import node, and let's import our DOP network. So I will put it here, and the name of our object mask is going to be our car RBD packed object, and let's gonna put it here, and we're gonna to fetch geometry from a DOP network. So that it's what we have now, and this one was also in our DOP network. From here, we have to unpack, because now we have packed fragments. We have to unpack it. Okay, so now we have polygons, and the real magic happens when we put a point deform. So point deform, it's a node that we're uh, uh, gonna stitch all our fractured geometry in one single mesh. So it has three inputs. It's mesh to deform, rest point lattice, and deformed point lattice. So deformed point lattice, that's one that we did in DOP network. So it's going to be a sort one. Okay. Rest point lattice, it's our rest position, and rest position of packet primitives, it's assemble node. So let's print here, and we have that was our rest position, and we also have to unpack it and put it in second input, and first input is really our zero position that we gave to our car. So let's connect it here in the first one, and let's see that what we have now. Boom. That's all the stuff that we tried to make, and as you can see, it's all keeping together. So we can see a denting of a car, and this is one only for one part. Let's make it null, and it's going to be out body final. Okay. So this is only one part of a car, and as I promised you, I will go through all the car. I will give you explanation how I did, but the principle is the same. So you have to do all the separation for different parts and create all the constraints in DOP network and simulate all the parts together. So that's it. And let's check my heap file that I created for you. And now let's make a quick walkthrough my animations that I prepared for download. As you can see, we have different parts of a car. So let's see how I did it. So as you can see, I just separate everything in different groups, and I bring a car. Sorry, it's going to. Okay, I bring a car. This is a car that I got. I converted it to polygons. I make a zero position, and the uniform scale 0.001, and also transform it for destruction. Okay, and from this one, as I told you, and as I explained in the tutorial, I'm gonna to separate different parts of the body. For example, for skeleton, I did a skeleton setup. For bottom part, I did a bottom setup. And I just keep a group of the car. As you can see, we have 17 prim groups, and I just separated every group and did Voronoi setup for everyone. And we also have some parts that, for example, glass parts. I created RBD material fracture because it's all already have a preset of glass here. uh, let's see how it looks. It's cooking now. Okay, so that's RBD material fracture node has already a setup with material type of glass, and that's what we have in preview. Okay, and also we have some parts that are not destructible. For example, I kept doors as simple RBD, and also seats. So every wheel I just separated in different objects. Okay, so that's a setup that I did for RBD. After that, I created a main DOP network, and in DOP network I just bring every setup that I created, and let's gonna see how it looks. It's cooking now. Let's wait. Okay, so I bring a skeleton, I bring bottom part, plastic, glass, and also this one's is a packet primitive. Okay, so that's at once with voronoi fracture. This one doors, seats, and all the wheels. It's a simple RBD object. Okay, and I merge all the ones together. I did a rigid body solver, and after this I just created different constraint networks. For example, for a skeleton constraint, I created a bullet soft, and for example, for a bottom constraint, I created a bullet soft with glue constraint, and for plastic, I created only glue plastic constraint, and after that, I merge all in all with ground plane, created the gravity, and that's all the animation, and I brought it everything in a sub level. Uh, so parts that we have to unpack I unpacked, and parts that it's for example seats that are only in BD, I just brought a geometry. So I deleted some attributes that I didn't need, and just cache all the files, and that what that's how its final simulation is gonna to look. So we keep this mesh together, and we can see that the mesh is denting, and some parts are brokeable and some parts are not brokeable. For example, wheels staying together, and also seats staying together here. So that's it. So this file if you want, you can download it from my Gamma rods and uh, pay me a beer if you want. But that's a simple setup that you can create with different cars because principles are the same. So thank you for watching and see you next one. Bye bye.